Hey gang, hope everybody is doing well. We're going to be doing 8.4 similar triangles today. Just a couple things. First of all, I appreciate most of you guys who are keeping up with your work, staying on top of everything. Just make sure you stay on top of everything each day. Any issues, contact me, contact the tech department. And a new thing we're having now, I know this is I'm doing this on Thursday of the previous week that you're seeing this. They're taking tech appointments only. I believe that's on Tuesday 10 to 12, but just keep, some of that stuff can be changing as you go, but you have to have an appointment. I think they had too many people there at one time, and it's for everybody's safety. Another thing, make sure, most of you guys are doing this, but some of you aren't. You've got to show your work. Make sure you're showing your work, because obviously at the bottom, I'm giving you your answers to check. You just can't write in answers, okay? You're not going to get any credit for that. You have to show your work. Can't stress that enough. And again, any questions, best way to reach me is via email. Okay, 8.4, similar triangles. We've done a decent amount with similarity in this chapter. And the warm-up basically is going to be just going over what we've done. If you look at, in the diagram here, triangle ABC is going to be similar to triangle DEF. You want to find the measure of each, either angle or side that they ask you for right here. And if you look here, you look at angle C, okay? Angle C right here, that's going to line up with angle F. So we know if C is 86 degrees, angle F is also going to be 86 degrees. So it's going to be 86 degrees for angle F, okay? Because we know that C and F are going to line up, okay? So that's the big thing you have to know here, is that everything is going to line up. We also have angle A and angle D. We know they're both 62 degrees, so we know angle A is going to be 62 degrees. Okay? Can't stress enough that everything in the similarity statement is going to line up. Okay? And angle B, the way we're going to get angle B is basically just, we all know that all three angles of a triangle add up to 180. So we are just going to add your 86 and your 62, and we're going to get 148. We're going to take 148 away from 180, and we're going to get 32 degrees for the measure of angle B, okay? So that's how we're finding all of our angles. You can put, if you want to put it in here, 32 degrees, okay? And then we look at a side here. They want to know what FE is. Well, the sides that we have AC right here, 18, and that's going to be over DF. So AC over DF, okay? And that's going to be 18 over 12. And to find FE, we look at FE, that's what we need to find. We can make that our X, okay? And FE is going to be in line with CB, okay? CB right here, okay? So FE, all right? FE, look right here, in line with, FE is in line with CB, all right? So what we have to do, and again, we're going from this triangle to this triangle, so we're going to do CB, that's going to be 30 over FE, which is going to be our X. Okay, and we cross multiply, and we're going to end up, when we solve this, we're going to end up getting X equal to 20. Okay, X is going to equal 20 when we cross multiply and solve this. X equals 20. Okay, we've done enough of these proportions. I think we know we multiply 30 times the 12 and get 360, and 18 times the X, and we divide the 360 divided by 18, and we're going to get 20 for X. Okay, so that's our warm-up, just getting ourselves ready for what we're going to see when we're looking at similar triangles. Okay, what we're going to do first here is we're going to write our statement of proportionality. Okay, in our statement of proportionality, you want to see what sides are in proportion to other sides. Basically, let's look at this as a whole. We've got, excuse me, we've got our small triangle right here, TEC, okay, or you could say ETC, and our bigger triangle is going to be B, right here, TW, okay, so you're really looking at a smaller triangle right here, and then the bigger triangle, you can even put that on the outside, but you can clearly see what sides are going to line up here, okay? And you can also go by your similarity statement, okay? In your similarity statement, you know that TE, okay? TE right here is going to line up with TB. This is the side of the small triangle. This is the side of the bigger triangle. Okay, so TE would be in proportion to TB. All right. Then the next one we see that TC right here, the other side, TC is going to line up with TW. TC lines up with TW. Okay, and you can see where TC is the middle one and the end one, TW, middle one and the end one. All right, TE, the middle one and the first one, TB, middle one and the first one. So again, the big thing about proportionality and similarity is that everything's going to line up. All right, and then the last one we have is EC. Okay, EC is going to be proportion to BW. Okay, so this is our proportionality statement. Okay, and in this particular one, we're going from the small triangle on top to the big triangle on the bottom. Okay, all the different parts. And they want you to find the measure of angle TEC. They want you to find a measure of angle TEC. Well, let's look at this. We know that in proportional, or two triangles that are similar, that all the angles are going to be the same. So we know that angle B, okay, angle B right here is going to be in proportion, or it's going to be, I'm sorry, it's going to be congruent to angle E. They're both going to be, angle TEC and angle B are both going to be 79 degrees. Okay, they're both going to be 79 degrees right here. Okay. Now what they want you to do is they want you to find ET and BE. Okay, so if we look at this, we're going to look at our, get rid of this here, that was from before, our full length here of 20. Okay, and you can do a couple things here. You can make this X. Okay, if you make that X, then you know that X, the small side, over the big side, is going to have to equal the small base here, 3, over the big base, 12. Okay, because this is the bottom of the small triangle, and this is the bottom of the big triangle. And we know that EC is in proportion to BW. Okay, so that's going to equal 3 over 12. And if you want to, again, you can reduce this down to 1 over 4 just to make life a little bit easier. But these aren't really terribly high numbers to worry about anyway, so we're not really too worried about that. So we're going to get 12x equals 6 equals, 12x is going to end up equaling 60, and you're going to end up getting x equal to 5. X equals 5. Okay, so ET right here equals 5. So we're saying X for ET equals 5. Okay? We know if this equals 5, we don't even have to do anything else with proportions. If this equals 5, the whole thing equals 20, then obviously this is going to be your EB, or your BE is going to end up being 15. We just took, with the full length here is 20, we took away 5, so BE is going to be 15. Okay? And that is example number 1. Okay. And also, like I've been doing, on each page on your worksheet, I'll do the first problem in the examples, in the set of examples with some notes alongside it to help you out with that also. But again, as I always stress, if you have any questions, feel free to shoot me an email and I can answer anything. And we're going to look at our angle-angle similarity, excuse me, similarity postulate. Okay, if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are going to be similar. Okay, they're not going to be congruent because, again, we always show the example. If you have something like this, and if this is 30, 60, 90, this also is 30, 60, 90, okay? These two triangles are in proportion, or they're similar. Obviously, they're not congruent, okay? So the angle-angle similarity postulate only holds true for when we're talking about similarity, okay? Because they're in proportion, okay? And we're going to shoot down here and just look at a couple of examples and see whether the two triangles are similar. Okay. We're going to look at this triangle here, and we're going to end up getting our third angle here of, you look at here, you've got your 2, your 92 and your 57. So you're going to end up adding that and getting 149. You take that away from 180, and we're going to get this angle at 31 degrees. All right, and you can look at this right away and know that these two triangles are not going to be similar because you have to have two. If you have two angles that are similar, the third angles, or two angles that are congruent, the third angle is going to be congruent. So there's no way here that you're going to have two triangles that are congruent, because you look here and you've got 92. Okay, you still have the 92 here, you're good there. 92 and the 41 is going to give you 133 and 47 for angle D. Okay, so you've proved right here that you don't have all of your angles congruent. Okay, you don't even have two of them that are congruent. So this is going to be not similar. Okay, it's not going to be similar. Okay, and we're going to look at our next one right here, and we're going to end up getting, you have 77 and 48, and we take that, we add that together, 77 and 48 are going to end up giving you 125. We take 125 away from 180, okay, and we get 55 right here. Okay, again, we know all three angles of a triangle are going to end up equaling 180. And we look at this, we don't even have to go and find this one. We know if two angles of one triangle, angle B and angle C, okay, angle B is going to be congruent to angle E, and angle C is going to be congruent to angle F. We know by the AA postulate the triangles are similar. Okay, so we know those two triangles are going to be similar. Okay, And I'm going to raise this up a little bit here. And we're going to look at C and D. All right. C and D, you've got 55 and you've got 82. The problem here is that we only have 43. There's no way of knowing what these other two angles are. So, if we at least were given another angle, we'd be able to get the third one. We'd be able to prove whether it's not similar or similar. But here, we don't have enough information. Okay, so there's not enough information. Not enough information right here. And then here, we've got these two angles congruent because we know they're vertical angles. Again, when I introduced vertical angles, I told you guys we would see it over and over again, and sure enough, we're seeing it a lot. And then you've got the alternate interior angles right here. Okay, angle A and angle E. Remember, this is like a transversal coming through. You've got two parallel lines. There's arrows dictate these are parallel lines. Okay, so this is going to be similar, okay, by AA, the angle postulate. Yes, the triangles are similar. Okay, so that's basically a few where you saw either they're similar or they're not similar by the angle postulate. Okay, we're going to move our way down to example number 3. And in example number 3, the first thing we want to do, okay, if they say use a diagram to complete the following, MON is going to be similar to, we know they're both similar because you've got two angles of one triangle congruent to two angles of the third triangle, or a second triangle, I'm sorry. And you can also know now that the third side here is going to be congruent. So if you just go right along here, MON is going to be similar to GHI. G is the first one with one arc, H is the second one with two arcs, and then I is the third one with the three arcs. I and the N are going to be congruent, okay? And then again, I can't stress enough how you really have to line everything up here, okay? So MN, first and the last, is going to be in proportion to GI, okay? ON is going to be in proportion to HI, and MO is going to be in proportion to GH, okay? So that's a little bit there on proportionality statement right there, okay? And they want you to solve for X and Y. Well, we know that MN is going to be in proportion to GI, so X is going to be over 10. Okay. And we can write our one right here, ON, okay, is in proportion to HI. Okay, so that's going to be 16 over 12. Okay, 16 over 12. All right, and then we solve that. We do 12x equals 160. And we divide through by 12. And we're going to end up getting 13.3. Rounded off there, thereabouts. Okay. So x is going to equal 13.3. All right. So we can use this 16 over 12 again, and we look at our y. We're trying to find our y, and we know that MO over GH, okay, MO over GH, y over 8 is going to equal 16, again, over 12. Okay, ON over HI. They're the two that you know. All And if you wanted to, again, you could also reduce this down to 4 over 3, okay? Because 4 goes into 12 3 times, 4 goes into 16 4 times. You have some lower numbers to work with, but these numbers aren't too terribly high. But when you do this, you're going to get, you have your 12y equals 16 times 8. Okay, and that's going to be 128. So 12y equals 128. We divide through by 12, divide through by 12, and we're going to end up getting 10.6 for y. Y equals 10.6 for your answer right there. Okay? So that is B. We got A, B, and C of that one. Okay, for example number 3. Okay, the last one we're going to do, example number 4, and this is where you really just need to look at what you have right here. They want you to find out what QS is. Well, you can see if you flip this over, okay, that your 6, if you put your 6, that's going to be over what we need to find here, x. Okay, 6 over x. Okay, if we went from the big triangle to the small triangle, and again, QS is what we're trying to find. 6 over x is going to equal the full base, because we're talking about this whole big triangle. Full base here, this is going to be 24, and it's going to be over 16, the full base down here. Okay, so 6 over x is going to equal 24 over 16. And when you do the cross multiplication right here, you're going to end up getting 96 over 24. Okay, we cross multiply. And then we divide through by the 24, and we're going to get x equal to 4 right here. Okay? And that's it. Similar triangle. So again, you'll get the worksheet 8.4 that'll have some additional examples on there. But you have this to go by, and as I always say, you see, you hear me keep saying, if you have any questions, definitely email me, and we can go from there.